7, assessment 1 review. All right, pause. I might take a look. I see if there's something I did in there where you're like, hey, there's more than one answer. This is where you need a little circle chart where you're going to need it at the end. When you get to take out notes, you won't get to use it along the way. So when you do the 6 problems in 4 and 5, you will get the first answer with your fingers. Then you'll need to wait for when it's time for notes. Take those out and do it. And I can tell that, I'm going to see who utilizes it to their advantage. You'll get to do part of the test today, but clearly you're going to have to finish the test on Thursday, which means for some of you, if you use your time wisely, to do your test, the part you know today, save the part that seems hard for next time. I mean, try it, whatever, but review your notes, review videos, whatever, between now and then. In any case, let's say I'm doing sine. I'm all happy about sine because I'm counting up from the bottom. I need 2 of those. 1, 2, hooray. I know it's 45 is a key angle. But when I look at my notes, the little circle thing, 45 will have a positive sign. I need a negative sign. For those who know the signs, they're at the bottom of the circle. So I need some degree that's in the bottom half of a circle. Like, what are bottom half circles? 270, he's in the bottom half of the circle. 330, he's in the bottom half of the circle. When you just take out that chart, it's going to have the second number out of the 2 pairs as a negative. So that's 2 or 2. All right, so these actually should be easy once I take out my chart. So I save these for the very end, take out my chart, I get 6 problems for free. And there'll be 2 per for that. Now, if you're like, I have no idea what he's saying, that means you weren't here Thursday or it just all has gone away from you. So do this. Pause for a moment. Let's say I put that over 1. So now I'm really asking the question, how can I get a 3 on the top and 1 on the bottom? Well, if I fold this finger here, and there I go. Radical 3, when you do tangent, is radical, as she would say, root fingers over root fingers, or radical over radical. In other words, radical 3 over radical 1. Radical 1 is just a 1. Anything divided by 1 is just that thing. So this radical 3 is me first going, okay, I'm going to flip my fingers in the end for tangent. How can I get a 3 on the top? Well, even if I had a 3 on the bottom, then when I flip it, I get a 3 on the top. Okay, 3 over 1, that's cool, but where's their, oh, yeah, so, no, that's it. It's inverse, so they can feel it. Inverse. What's the problem? 2x plus 1, write this down, 2x plus 1 equals 17? Yeah, 17. This is old school. Most of you know how to solve this. You solve it by using the inverse of the different properties. The inverse, you undo things with the inverse. They're going to compare the word inverse with reciprocal. With reciprocal, you just flip something upside down. You don't do like any work, you just flip it upside down. The inverse is the thing that you use to solve a problem. As a matter of fact, write that down. Inverse. Thing used to solve a problem. Thing used solve problem. Problem. And by solve, that's a cool M. By solve, we mean isolate the variable. Ooh, I'm all like talking like I'm like, yeah, it is warm. Yeah. I'm all talking like I'm a math dude. Solve means get X alone. Like once X is alone, like I just solved it. Solved it is high school talk for like, we don't like that girl or guy, we're not going to talk to them. We're going to isolate them. When you're being mean like that, you're being a mathematician. And we would want that. Isolate, solve, get alone, isolate. Isolate, which is interesting because iso with isosceles means same. I wonder how it operates in the word isolate. Or maybe it's, it happens to have the same letters but doesn't mean the same thing. All right, why is he saying all this? Because when they talk about the inverse of sine and cosine, we're not used to messing with it. And even in this unit, we didn't do it back in geometry like unit 6 or 7. You had to solve using the inverse of sine and cosine. In any case, let me do the inverses. So you can go like, okay, I know what you're talking about. Step 1, do the inverse of plus 1. It means kind of do the opposite. I'm doing the inverse. Step 2, to solve for x. to solve for the letter, to isolate the letter, I do the inverse of that. Voila, I have the answer. I solve for x. I use the inverses to get those answers. All right, Thomas, how can you use the inverse of a sine or cosine to help them out on that? Let's see, 1/2 radical 2 over 2. Yes, please. Radical 2 over 2. I will remember you for that, just so you know. Yeah, there's one kid. Every day you go to the restroom. Like on good time, then Keith go to the restroom. He was drinking alcohol and came out happy, good times. I don't think he's doing that, but I'm just saying. I got it on tape now. All right, here we go. Hey, Thomas, go ahead and find the sine of radical 2, because he's famous, over 2. Just out of curiosity, anybody just like in their lives, this moment, you know the answer, like what degree x needs to be to produce a radical 2 over 2 for sine? Anybody know it? You can just say it. Yeah, 45. That is cool that you know that. Like, most people are like, I don't even know what you're asking. Like, I don't even know the question. This question says, what degree does sine, x need to be so that when what degree does x need to be so that when I take the sine of it, it'll spit out a radical 2 over 2? That's what it's asking. Now again, with the fingers, we know it's 45 degrees, but the question is, how does it relate to this question? And here's how it relates. This is the long road to the end. Hey, Thomas, please solve for x. Please isolate x on this problem. How do I get rid of sine? I do the inverse of sine. Well, what's the inverse of sine? Like, you mean you divide sine on both sides? Or like you subtract it? Like, no. How you undo sine is by using the inverse, and the inverse looks like this. I'm going to inverse on both sides. I would put this in front of it if I could, but I didn't leave enough space, and I'm going to have to put it in front here, but I don't have enough space, so I'm going to squeeze it in, and hopefully someone doesn't think this x thing belongs to this problem, and now it's all confusing, like, what happened to the red x? It's not part of that problem. I just messed up. I apologize for what's going on there. But here's what I would do. I would do, did they say sine inverse? That x there? I'm not going to put it, but I know they'll put it there. This is the opposite of sine. I think sometimes called sine inverse, but I know also sometimes called arc sine, ARC sine, which we're going to write down in just a moment, so that we can have both versions of it. Hey, what happens here? Beauty. Sine gets canceled along with this guy. They're opposite guys. They're inverses, leaving just the x. Hello. And when we do the arc sine in the calculator, somehow, I don't know how we do it, but we punch in radical 2 over 2, there's a button on your calculator like arc sine, and then boom, on the other side, it spit out like a 45. Because the calculator knows that when you punch this in, it's saying, for which degree would we get a radical 2 over 2? The calculator will spit out, say, 45. I almost wish you could punch in your calculator right now. Yeah, let's pause and have you do that real fast. Answers coming in blue now. Or if you want to write the word version is arc, A-R-C, sine, and arc cosine. Those are the two ways you write the opposite, also known as the inverse. Hey, what happens when you take the inverse of an inverse? It returns you to the original. That's what I'll write. It returns you to, look at that, you. Original to original. Whatever you had to begin with, if you do the inverse to it.
I think there's you too.
Because I put you and people in academia, people who are just so I don't do a lot. Hey, what are the differences? What are the similarities? Basically saying, graph them on the same line like you did before. Let's go. 25, 70, 50, 75, a dollar. For sine, you go up, you go down. For cosine, you start up, you end up, you're down here. So basically, draw the two things and say what's similar, what's not. I would say at least do two similarities and two differences. What you got? Dang it. All right, then just use your calculator. All right, pause for a second. Secant equals, it's the reciprocal of cosine. In other words, secant over 1 okay. Here's what I need you to do. In your calculator, go ahead and punch in y equals cosine x. You know what the picture's going to look like. It's going to be a little wavy thing. As your second function after y equals cosine x. Even I don't know how you punch in cosine x. Is there a way to punch in cosine x? You just, what did you punch? The close button?
Close.
Okay, okay. The second one, the secant, yeah, the picture's going to be not that great. The second one, you're going to put in y equals, you could try and put in secant, but I don't think secant is going to be there. So what you're going to do is you're going to put 1 over cosine x for the second function. So the second function, I'm punching in y equals, where am I? Oops, didn't want that. Oops, that was a bad idea. Y equals 1 divided by, again, if you couldn't get in the first one, make sure you get in the second one. Cosine, I guess I'll put x. Yeah, that'll work. Close it up. Hit enter. Graph. Mine says invalid quit. Is anybody's thing not showing a picture? Ooh, yeah. All those U's. Yeah, look at those U's.
Wait.
Oh, yeah. Get some U's, get some U's.
How'd you do that?
Once you get the U's, basically, again, you're going to look at the picture. The U's are the reciprocal of cosine. It's 1 over cosine. So if I'm drawing it on here, my blues are the U's. Hey, blues. Booyah. 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 And again, my job is to make at least 2 observations of the blue versus the green. Just say stuff. Say whatever you see. It doesn't. Okay, so yeah. So what will happen? You guys will still get to taste the test, but feel less tasting and more next time. Hey, what happens when you multiply a trig function with its inverse? It's almost like saying No, I'll just do it. What happens when you do multiplication then division? It undoes the thing, but we're actually going to show it. So what's a trig function? And it's, let's see if we can write it down. A trig function with its inverse. Oh. Let's show it. We did it up there. What happens? I'm not sure how you're going to say these words. Say you have cosine. We did cosine above. Why don't we do it with sine so they know it works both ways? Say you have sine x. And I'm going to multiply sine x with its inverse. Can someone tell me one way to write the inverse of sine x? We just gave it
Sine -1. Or sine.
Yeah. Either way, you can say it. So I'll do both versions. Sine inverse. We don't say -1 because, of course, other math will get all mad about that. That is not a power. Okay, we get it. It's just a designation. This is our way of saying this is the reverse, the opposite of this. Just like multiplication and division are inverses, like addition and subtraction are inverses. Well, so is sine and arcsine. they're opposites. They undo each other. However you start it, if you do division after some multiplication, it undoes it or whatever. All right, so let's see if we can. What happens when you multiply these? It equals just x. I'll put they undo each other. They undo each other. I wonder what each other. I wonder what a real math person would say. I wonder how they say it. They undo each other. Undo. Oops, dang it. Is there a 5? Undo each other. I'm going to underline undo to be the 10. I'm going to erase some stuff from around here. 10 is what I was doing for number something else when I was doing the red and the green in this picture here. I did red and green thinking they were asking just about sine and cosine. I'll compare the red and the green. Okay, well, what can you say? Oh, they're equal at certain places. Fine. Yeah. This is my best work. All right, so clearly they're equal at certain places, wherever this is at 25 cents. No, that's not 25 cents. Somewhere here, the red and green, they're equal. They both, their amplitudes are equal. Anything I can say about them? They're not equal at the 50-cent mark. What else can I say about them? They end. Their beginning and their endings are exactly in the same place. So basically, name all values where cosine and sine are equal are the inverse. Okay. So what I was doing initially there was just identifying all the stuff that I could say by just looking at it. But now that I read the question, name all the values where sine and cosine are equal. Okay, I can circle that. Obviously, you guys are equal right here. You're the same. You're equal right here. You're the same. Anywhere else? No. So there are only two places where they are the same. This should be interesting to see what somebody says.
Wait, we can't just draw it as a picture, right? That gives some type of explanation.
Right. Because if you're just circling, you're.
No, I know.
Yeah, but for sure, I wouldn't give you a 0.
Yeah.
So whatever the points are, I'd probably take all the way except 1 point. But I think they're only like 2 or 3 points. So you basically get half credit. Yes.
For secant, does it start on 0, 0?
Secant.
Is that like it's carried? I mean, it's carried. I'm figuring out what's going on.
This secant is the flip of cosine. It begins technically on the opposite side.
Before you move it, like at all. Before you move it at all, like does it start at 0, 0?
I would say no. I would say no, though the weird answer is going to be, depending on which one you're looking at. If I were saying it, he's probably going to start on this side, thinks it's going to be start probably like a negative 25 cents or negative 50 cents. It's probably a negative 25 cents. If that means anything, 25, 50, 75. But if you go this way, 25, 50, 75, this blue guy, the secant, he probably begins here at what would probably be nothing, dang it. Yeah, he'd probably be the negative 25. But let me do something, go to Scholar's Point so that you know what you're writing. True, if you grab both of them, you will see where they are equal. The other part, and then I'll talk about the inverses because it's going to be also calculated for the inverses, so you're not going to be able to just see those. But for the regulars, you have to identify what this point is on the x-axis. In other words, I know you're 50, and I know you're 25. My dots aren't going where they should. Now, hold on. You're 50, you're 25, you're 75, and you're $1. My picture's off because I moved the sum, but the point I want to make is, it's true, the 50, 25 cents is up high, 75 cents is down low. But where they intersect is right here, whatever this is. More than likely it's going to be half of 25 cents. Hey, what is that in degrees? Well, I know you're 180. is your half. You're 90. Someone say what half of 90 is? Yeah. So on these, when you actually put in the real numbers, not the money thing that I use just to help you draw the picture, 45 or 90 is your pi, your half a pi. Yeah. 5/4. And you were 45. The blue guy is 1 over cosine, also known as secant. And then in your calculator, you would need to do, so this is one comparing these two guys. Are their inverses equal as well? Is asking you to do the following. Now this is definitely a calculator, you can sketch it. I need to do 1 over cosine and do 1 over sine. Oh shoot, those are their reciprocals. Here's what I'm going to do. For the purposes of how I'm going to grade, how can I mark, let's put NA. Let me just do NA. NA for the second part. Because what they're trying to find out is, hey, what would cosine look like and what would sine look like? I was about to write their reciprocal, that 1 over thing, which isn't what they're asking about. And if I was about to say that to you, then chances are that's what you'd be referring to. So when you get here, and I'll refer to it, I'll remind you, hey, just do the originals. Where do they meet? Where are they equal? And we'll leave it at that. The second question about the inverses, we won't do anything with that.